Hello everyone, my name is Anton Boyko and today I'm here with my new friend Mr. Miyagi, and what we will try to do during the next 45 minutes, we will try to find an answer for this question, creating a workflow orchestration engine based on Azure Durable Functions. Was it worth it? So let's start from the beginning. Let's define the goal that we were pursuing. So I used to work on a project, and that was basically the multi-tenant app. And for that multi-tenant app, of course, each and every time when we onboard a new tenant, a new organization to our app, we were supposed to create a dedicated and isolated piece of infrastructure. That can be the database, the storage, and so on and so forth. Because we didn't want to do that manually, we came with an idea that it will be nice to have an automation engine that will do that for us. Okay, so at the beginning, we were operating under the following assumptions. First of all, we knew that all the activities that we need to implement as a part of the orchestration flow will fall under those three buckets. That can be either a call for the external API, or that can be wait for the human interaction to basically get an explicit approval or rejection of something, or that can be read-write actions that we will run against our database or other kind of the data storage. Next, we knew that each activity may take from 30 seconds to up to 10 minutes to finish, and the entire flow will take up to 2 hours to finish. And the third thing was that some of the activities we may want to run them sequentially, but some of the activities, to speed everything up, we may want to run in parallel, and our engine should support that as well. Based on that, we had a pretty small list of must-have requirements. So first of all, we need to create the engine itself. Then, as I was saying again, we need to be able to pause and wait for the human interaction, and we don't need to be dependent on that non-persistent memory. Because when we were studying all the different options that are already there on the market, we noticed that there are a lot of products which basically will persist your state in RAM, and because we're operating in a cloud, because we're creating a distributed system, we cannot afford that, because each host that runs our orchestration may be rebooted, may be recreated in some other place, even when we run some code on top of that, and the state will be lost, and I don't want that. So that was our third mandatory requirement. Additionally, we had a list of nice-to-have requirements, because we were thinking, yeah, we're creating something, so maybe let's try to make it a bit bigger so we can reuse that on other projects, or maybe even in the same project, but for different scope of tasks. So the first requirement that we had here is we want to be able to run that engine outside Azure Cloud. We don't want to be vendor locked on Azure Cloud only. The next one is that we want to be able to replace the engine itself with the new implementation in 1 working week. So we assume that that will be a good idea to start with Azure Durable Functions, but we realize that if that assumption was wrong, we need to have a plan B. We need to have a new option which we can easily use here, and basically not throw away all the implementation that we created so far. Additionally, we understand that at some point we may have new team members, so that's why the engine itself needs to be easy to learn, and the new team member needs to be onboarded in up to 40 hours to be able to start working with this engine. Additionally, we understand that it's not always that we will be able to test all the things manually, so we need to be able to create some test automation against our workflow engine. And as a nice-to-have requirement was that we need to be able to cover the workflow engine itself, the orchestration itself, with the unit tests. Also, As I was mentioned before, we knew that we will use 3 kinds of activities at the beginning, but at some point, if we need to extend those, that also needs to be possible. Additionally, and this is another important thing, in case the orchestration failed because, I don't know, because of any reasons, for example, the dependency failed, we were trying to create resources, but we run out of limits, so then we need to go request more resources on Azure subscription, so they will kind of provide us with more cores, more storage accounts, and so on and so forth, and then I want to rerun that workflow orchestration again. That needs to be possible, and that needs to be provided kind of, out of the box, and that needs to be transparent for the end user, for the caller basically as well. So that was it, and based on that, we decided to take some actions. So as I was saying already, we were already using a lot of Azure Functions in our project, so that was one of the reasons actually why we decided to give Azure Durable Functions a shot. If you are not familiar with the Azure Functions themselves, let me just do the quick introduction for you. So in terms of Azure Functions, what do we have? We have our code. This is basically our function. It can be created in, I don't know, .NET, it can be Java, Node.js, Python, PowerShell, whatever. Then, for your code, you have a trigger, and that trigger basically describes when we need to run this code. That can be, I don't know, a new message in a queue, that can be a timer, that can be even an HTTP request, that also will be a trigger for our code. Additionally, we may have some extra inputs. Let's say that your trigger will be a timer and your inputs will be, for example, some files that you store in Azure Blob Storage. Also, you can have outputs. A good example here is when you are using the HTTP-based trigger, the HTTP request implies that you need to create an HTTP response. So in that case, your response will be the output. Also, what's worth mentioning here is that you are not limited to one output only, because the HTTP request can first create the HTTP response, and then additionally it can, for example, put some files in a JSON format or whatever to the Azure Blob Storage. In that case, you will have 2 outputs, the HTTP response and the Azure Blob Storage. Additionally, you have the built-in engine for logs. You can always trace, using this logs engine, what is happening within your functions, because all those functions, they run, okay, that's not mandatory, but this is my favorite way of running those functions, they run on top of hosts which are stateless and they are ephemeral, so they can appear and disappear basically for each and every run. So you will be unable to get there and investigate something. The logs engine, basically your only one option to get at least some observability for your code. All those things, they are wrapped within the function runtime itself. And also, you may have some external services. I was mentioning, for example, Azure Queue. I was mentioning the Azure Blob Storage, also that can be Service Bus or whatever. And another cool feature which I like about the Azure Functions is that you do have this concept of built-in bindings. So you don't even need to create those connections for the external services by yourself. You can use the declarative format and you can configure that binding, and it will happen for you under the hood, which is really awesome. So now let's talk about the Azure Durable Functions. So how it differs from the regular functions. So the difference is the following. The function runtime is the same. So it's literally the same runtime. The durable function is just an extension that they built on top of it. So now, additionally to all those components that I've already described, you have this durable runtime extension. Because it's durable and because, as I was saying, the host is ephemeral and it can disappear at any moment in time, you do need to have an external storage. And your durable runtime needs to be connected to that external storage. Additionally, for the triggers, now you can use HTTP-based triggers only. That actually makes your inputs to just one input, not plural but singular, because now you can get only the HTTP payload, basically the body of your request, as an input, and that's it. Also, the code structure will change a bit. First of all, you will need to implement a trigger function, which also will be called the starter function. Additionally, you need to create a function which we'll call the orchestration function, which will describe the flow, basically, of the orchestration. And then you need to create a bunch of activities, the bunch of built-in blocks, and the orchestration function will just manipulate those activities. There are a few more things worth mentioning here. For example, for the starter function, it needs to be everything less. When I was creating those slides, I was thinking about, yeah, let's put something like logicless, stateless, and so on and so forth. But technically, everything that you can imagine, you need to avoid doing that here in the starter function. So the only one job that the starter function can do is receive the HTTP request, grab the payload, maybe do some, I don't know, like the validation of the data contracts or something like that, and then pass the control over to the orchestration function. That's it. Now, the orchestration function, it needs to be deterministic. That's the mandatory requirement, otherwise it will not work as expected at all, and we will dive into more technical details on that topic a bit further during this presentation. So what it means to be deterministic, let's basically take this as an example. The definition of deterministic function is a function that always returns the same output from the same inputs. So if we will take a database query, something like select max and min price from the goods table, as long as the goods table remains the same, this function will always return the same results. But this function, for example, this query, for example, it's non-deterministic, because if you will call select get date and it's now like 10 times in a row, you will always get the different results. As for the activities, the requirement here is that they need to be idempotent. What that actually means? That means that if the activity needs to change the state of the system, then if I will run this activity a few times, it needs to latch to the same state change. Let me actually show you an example here. So for example, this query, this is the idempotent query. So delete from goods table where ID equals 42. If I will run it once, if I will run it 10 times, it will always modify the system in a way that the state will be the same. Because if the record with ID 42 is present, it will delete it. If it's absent, the request still will be valid. It will run and it will do no modifications. So this is the example of the idempotent query. This example is not an idempotent query because we are inserting into the goods table, we're inserting name and price. And as you can see from here, this example, if I will run it 10 times, that will basically mean that I will have 10 laptops. But in fact, I wanted to have only one. So those are the things that you need to take into the consideration when you are creating something based on Azure Durable Functions framework. Now, let's say a few words about the cloud agnostic-ness. Okay, so the first part we will say about the function runtime itself. As you can see, you have a few options how you can run your function runtime, or how you can actually run your functions, to be more precise. So first of all, it can be either, let's say, code run, In that case, you have a host, and that host, it needs to contain the function runtime, and then you just upload your code there in a way of binary files, if it's, for example, .NET or Java, or the code files, if it's Node.js, and then you use the function's runtime to run that code. You can do that on Windows, you can do that on Linux. In both cases, it works perfectly fine. But one more option that you can take, that will be to run your code as a Docker container. In that case, you will basically use the base image of Azure Functions runtime, and you will create your custom Docker image based on that Microsoft provided image. The thing here is that the consumption and premium rows that you see here in this table, they relate to the way how you can host it in Azure, but there are two more options here, dedicated and Kubernetes. That basically mean that if you have a dedicated host, that can be, I don't know, your laptop, or that can be just yet another virtual or even physical machine somewhere in a cloud or on-premise, you still can run your code there. You can run it, as you can see here, as a code, or you can run it as a Docker container. I know that this is not in the scope of this particular presentation, but I used to create a lot of code, and I run that even on top of Raspberry Pi. I mean the code that was based on Azure Functions runtime for my IoT scenarios that worked like a charm. And the second part of cloud agnostic-ness is about the persistent storage. Currently, there are three options that you can take for your Azure Durable Functions framework. That can be either the default option, which is Azure Storage, or that can be the provider, which is called Netherite, which will basically store all the states on top of the event hub. So if you will have a huge amount of messages that will need to go back and forth, if you really want to do a stream processing kind of an application, then you should probably go for that one. And the third option is to use MS SQL Server 2019 as a storage provider, which basically means that I can roll it out in my on-premise infrastructure, and it will work like a charm, which we will actually also see in my presentation, but a bit later. So, 4 nights and 20 coffees later, we were able to present our first results. So let's talk about those. The first demo that I would like to show you will be about the orchestration itself and how those folks from Microsoft achieved the durability of the framework. Before we will jump to the code, let me just show you a few things here. First of all, let's take a closer look at this example. You can easily find it on docs.microsoft.com. So this is an example of Azure Durable Function orchestration flow. As you can see here, we have in 4 different activities, F1, F2, F3, and F4, and we are chaining them in one orchestration flow. And we are always taking the output of the previous activity and use it as an input for the next activity. The magic here actually happens within this context object. And this context object, as you can see, is basically an instance of an interface IDurableOrchestrationContext. And why this interface is so important, let me show you. So this is the part of the interface. I just write down a few methods from that interface. You can see the create timer, the wait for external event, the call activity async, but there is one guy here which bothers me a bit. This is the call HTTP async method. So the thing is that since, I don't know, forever, I was using a good old HTTP client to make my HTTP calls, and that worked like a charm. So the question is, why do I need to use a new method to call the regular HTTP endpoint? And this is the actual magic of this durable framework. This is actually where the durability happens, because when you will call the HTTP endpoint through this particular method, what will happen under the hood? First of all, Microsoft will instantiate the activity call. So in the scope of this workflow type, in the scope of this particular instance, in the scope of this particular step in the workflow, it will create a dedicated storage space. Okay, and what it will do, it will check, do we have any data in that storage space? If we don't, then what will happen, we will actually call that endpoint, we will get the response, and we will save it. But if we already have that data, because we may already call that endpoint as a part of this flow, this instance previously, then we will just grab that data, we will return it as an output from this particular method, but we will skip the HTTP call itself. And we will pass the execution to the next line, to the next step, basically. So this is the actual superpower of this framework, because the idea here is that Microsoft will achieve durability, it will persist, it will create the checkpoints, I will say, for your orchestration flow each and every time you will use the IDurableOrchestrationContext to do your call HTTP async, or to call an activity, or wait for human interaction, or something else. So let's actually see what we need to do in our code to make it happen. Okay, so let me show you some actual code. And we will start with the trigger function. So I do have here in my example two kinds of the workflows. Again, this is just the demo app, so no production-like code here. I do have two kinds of workflow, that's the provision workflow and the approval workflow. The provision workflow emulates the creation of the infrastructure resources, and the approval workflow emulates the human interaction activity. So what I do have here, let's start with the trigger function. This is the provisioning trigger. The approval trigger works the same. Let's see what we have here. As I was saying before, this function needs to be everythingless, and it actually is. So first of all, I'm checking the parameters. I'm basically grabbing the payload of the HTTP request, then I'm deserializing it to my custom module, which is provisioning module, which may contain some parameters for this particular orchestration, like the client name, the SKU, and so on and so forth. And then I'm using my durable orchestration client to start the new instance of this workflow. As you can see here in this start new async method, I am basically passing two parameters. First, the activity name, so this is the name of the actual orchestration, and second parameter, this is the input values. This is my model basically. And as a result, from this method, I receive an instance ID. So I received an internal ID of the orchestration, which I then return to the end user. So now let's take a look at what is happening within the orchestration. I will go here, and as you can see, the orchestration function looks extremely small, only like what, 4 lines of code here. And the reason for that is because I want to respect this spirit of basically decoupling the logic of the workflow from the implementation of the exact workflow engine. That basically means that before we will dive in Azure Durable Orchestration function here, we need to take a look at how we implemented the flow itself. So I do have in this solution one more project which called core, and this is the provision workflow from the core project. As you can see, this is the one method here, the run internal async. It gets the internal ID and it gets the input parameters of this particular instance of this workflow. Then I'm just doing a bunch of stuff. For example, I'm creating the workflow instance async. Why I'm doing that is because I know that Azure Durable Functions framework provides me with the way how I can store all my logs across all my instances of all my workflows. But again, because there were one requirement to be, let's say, agnostic of the exact framework which we use for this implementation, that is why I've just created a few extra tables for my own, with my own schema in the database, and I use those tables to store all those logs. And with the first line here, I'm populating those tables. Then with the second line, I'm doing it again. Now I'm just setting the state of this workflow to queued, and then within my try catch block, as you can see here, I'm basically writing a pretty much regular .NET code. So line by line, I'm updating the workflow status to in progress with comment like starting provision VM, configure VM, and so on and so forth. And then I do have the results list, and the results list, it will consist of 4 Boolean values, whether it's successful or unsuccessful to do that action. Again, I use that just as an example. You can just use tasks which are not returning any results. That's up to you to decide. So here we describe the flow, but now it will be really framework dependent to make the actual calls. And for that, what I'm having here, I'm having a set of abstract properties, basically a set of delegates. So when I'm doing the provisioning orchestration with the durable functions, as you can see, this function inherits the provision workflow, and therefore it implements all those delegates, all those properties, and then it basically sets those delegates to the way how I need to call the exact activities as a part of Durable Functions framework. As you can see here, within this init method, I'm receiving the context, which is my durable orchestration context, and I'm using call activity async everywhere. Literally everywhere here in my code. So this is the big idea behind it. So now when I basically get the control here, I will need to do the initialization, and after that I'm grabbing my parameters from the context again, and then I just pass all the control over to run internal async method. This is really kind of a cool way how I implemented that, and that basically means that the team who was working on this project now will be able to use this provision workflow abstract class and to cover it with unit tests and test only the logic, not the actual implementation. They can test only the logic of how the workflow goes from A to B and so on and so forth. So this is really actually a cool stuff. And again, because the requirement was to do that as agnostic as possible, then additionally we created a facade, and that facade is implemented with the Azure Functions, but with regular Azure Functions. So let me just show you how it looks like here. So this is my facade. So how it actually works, it gets the value of the environment variable by the name orchestration engine root path. It gets the root path of my host where I host basically the orchestration framework itself, then it just adds /API/provisioning trigger, which is the name of the provisioning trigger which I showed you before, name of this guy. Okay, and then what it does, it creates an HTTP client, a good old HTTP client I was talking about. It grabs the payload of the current request and it basically transfers that payload to the orchestration framework. And then, this is kind of a thing I am not really proud about, because I also wanted to return some information about the successful start of the workflow. So that is why I'm kind of pulling the database. I'm kind of requesting for the status for this particular workflow over and over again, once per half of a second. And the reason for that is because with the Azure Durable Functions, even, let's take a closer look here, even after I received the new instance ID from this start new async method, it doesn't mean that the actual orchestration started. It only means that the orchestration was queued, and that's it. So that means that I can actually get to my last line here, I can return this instance ID, then I can get this instance ID here on my line number 51, the internal ID that will be that instance ID I was talking about, but the actual orchestration, the flow that described here in my provision workflow may not run yet. Okay, so it was queued, but for now there are no hosts available or whatever, so no one picked up this task. So that is why here I'm kind of mimicking this this kind of a wait. I'm explicitly not kind of sending the response back, waiting for those results. The next one is the restart workflow. So let's say that I need to restart my workflow because it gets stuck or something like that. Let's start with the facade here in this example. So what I'm doing here as a part of my facade function, I'm get the ID of the workflow instance from the past that needs to be restarted. Then I'm again querying my database because in my own database I have this correlation between my ID on the facade and the internal ID for the Azure Durable Framework. Then I'm again getting the environment variable, constructing the URL, and this is it. If you will take a closer look at line 52, I'm using the put request, but I'm not passing any payload there, so the body of the request is actually empty. So now, if I will go and check the implementation here, what I'm having here, again, super simple code. So I get the internal ID from the segments, from the URI, and then I use again my durable orchestration client. I called restart async method. And as you can see, I pass the internal ID here, and then I get the new ID back. What I'm doing here on line number 43, I'm basically for the old workflow which gets stuck or whatever, for the old instance, I'm adding one more status, the final status, which is restarted. But the thing here that I wanted to highlight really explicitly is that if you will take a closer look, you will not find any input parameters. So this is the magic of the durable orchestration I was talking about, because the framework itself will create all those checkpoints for me. It knows what was the input parameters for the previous run of this workflow. By the instance ID, it knows what was the input parameter, so it can just grab it from the database and try to rerun the workflow again as it used to be a new instance. Another important thing is that when we are restarting the workflow, we are technically bypassing this trigger here, because we are restarting the orchestration function only. And this is actually one of the reasons why I was saying that this trigger function needs to be everything-less. It needs to be stateless, it needs to be logicless, and so on and so forth, because if you will have some logic here that will need to run for your orchestration, for your workflow to be able to start and finish, if you will try to restart it using the built-in mechanism, it will fail because this logic will never run. So that basically means that if you will not respect this everything-less concept, then you will need to re-implement such things as the restart of the workflow instance from the scratch, which is probably not the best idea to do. And also, just a quick look at the terminate activity. The terminate activity for the workflow, I'm basically doing that in the same way, in the same spirit as I'm doing that for the restart. So that was just kind of a quick demo of what you can achieve. At the end of the session, that will be a link for the source code. It's publicly available. You can get there, you can download everything, you can check it out in more details. And one more quick demo. I would like to show you how it works in real life. So what I have here, I have the Swagger UI for both of my functions, for the durable function and for the facade as well. On the left side, as you can see, I have two functions, two consoles that are running right now locally. So let me just trigger a few things so you will see how it actually works. For example, for the provisioning, let's create a new instance. Let's name it, I don't know, 2022, execute. Let's just wait a bit, we should get the results in a moment. Okay, so those are our results, and as you can see, the instance ID on the facade is 9. So what I can do now, I can go here, I can say try it out, instance number 9, execute, and those are the logs for instance number 9. It was new, then it was queued, then it started a few activities, and as you can see at this moment it didn't even finish yet, but now it seems like it's done. So let's run it again, and yes, and now we have a completed status here. Cool. So what we can do next, let's play a bit with the approval. So let's start a new approval flow, and let's say that the timeout for the approval is 1 hour. So I will queue this flow. Okay, and I have an instance which is 10. Let's go and check the status of this instance. Execute. So as you can see, the status is in progress and it actually gets stuck. The reason why it gets stuck, because now it's waiting for me to provide that approval. Okay, we can do that. We have submit approval result method here. We can try it out. That will be the instance ID number 10. The isApproved result is true. Let's execute it. Okay, perfect. It was successful. So now I can go to get workflow instance status, execute it, and as you can see now it's completed. Okay, that's cool, but let's say that we made a mistake, and what we want to do now, we want to restart this workflow. So let's restart the workflow with ID 10. Execute. Okay, it was restarted and the new ID is 11. So let's check the status of the 11. And as you can see, the status of the 11 is in progress. And if we will check the status of 10, then it will be restarted after it was completed. So what we can do now, let's say that we want to terminate the workflow with ID 11, execute. Okay, it was terminated. So now, if we will check the status here, we will see that it was new, queued, in progress, and then terminated. So all those things are already working out of the box. As I was saying, go check the code for yourself. If you will have any questions, feel free to ask them. As for the next demo, I would like to show that actually going out of the grid is as easy as 1, 2, 3. So let's say that the Mr. Miyagi wants to go rogue, so what he needs to do to make it happen? The first step will be to install package, and by install package I mean this package. So he needs to install a SQL Server data provider for Azure Durable Functions. And because currently the library is in a preview mode, we need to use this switch pre-release. The second step will be to provide configuration. First of all, we need to provide a configuration for the connection string for our database, which is pretty much obviously. And the next one, we need to provide a setting which calls Azure Web Job Secret Storage type, and we will set it to files. Because by default, as I was explaining before, the Azure Functions uses the Azure storage to persist everything. But now, because we want to go totally offline, there will be no Azure storage at all. So that is why we will be using the file system for that. And the third step will be to change the storage provider. So in your host JSON file, you will need to add this section. You will need to say that for my extensions, for durable task in particular, I would like to use a storage provider of type MS SQL. I will put the connection string name SQL database, which I created during the previous step. I will say that the 15 minutes, that will be the timeout for my activity. So if the activity will not be able to finish in 15 minutes, it will reappear again. And additionally, when I will be using this connection string, if there will be no database, or in a database there will be no tables required to store everything, then they need to be created automatically. So that's just so easy as I explained. Let's actually go and check what we need to do in our code to make it happen. Let me show you how everything works in a totally offline mode. So first of all, I will run the ipconfig command to show you that I've disconnected all my network adapters except one. This is the virtual adapter that I use to connect to my Docker containers. And now I can go here. As you can see, two console applications on the left side. That's basically the Azure Functions runtime, and these are my Swagger documentation. So what I can do here, I can run, for example, I can queue a new provision workflow, and as you can see, something starts to happen, and I even get a valid response. I can also create a new instance of the approval workflow, and it will work the same. Again, now I'm in total offline mode. In my Docker, I have only one container that is running. This is the container with SQL Server 2019. And if I will go to SQL Server Management Studio, you will see that this is my database. And for this database, I have that DT schema. And inside the DT schema, I have all the tables required to basically make it happen offline, to allow Azure Durable Functions to work offline. Let me show you the instances table first. So within this instances table, Microsoft stores all the instances of all the workflows that we run. So as you can see, there are provisioning orchestrator, approval orchestrator, and there are some data here. Some of them are running, some of them completed, and so on and so forth. Also, I can go and check my payloads, for example. And here, if you will take a closer look, then it tied to instance ID, and it has a unique payload ID, which basically means that it, as I was saying before, persists all the inputs, all the outputs for each and every activity, for each and every step in my orchestration. So that's actually how it's possible to run everything offline. That means that you can run it in a totally isolated environment. You can easily run it in any other cloud without any connectivity or any dependencies on the Azure cloud itself. All the stuff I was showing so far looks really promising, but as you can see, the Mr. Miyagi is not really happy about our implementation. So let's try to find out why he is crying. The first thing goes about storage providers. Under this link, you will be able to find more details on this topic, but as I was explaining before, there are three options: the Azure Storage, the Netherite, and MS SQL Server. For the MS SQL Server, the first issue is that it's currently in public preview, so you can already start building something with it, but because it's in a preview and there are no SLA, no support guarantees on that, I cannot recommend that for the production workloads. Okay, and the second issue with MS SQL Provider is that I cannot use it if I will host my durable functions in consumption plan. The consumption plan is a really cloudy way of hosting my application. So the application will always be there, ready to receive the request, ready to receive the workload, but if there will be no workload at all during the billing period, I will pay zero. So I do have this, my favorite consumption economy here, when I pay only for the amount of the resources that were actually used to do some useful work. But if I'm using the MS SQL as my storage provider, I cannot use the consumption plan. I can always use the premium plan. I can always use the CADA scaling support if I want to run my Azure Durable Functions on top of, I don't know, premium pricing plan in Azure, or the Kubernetes engine in Azure or other clouds, or even on-premise, but still the consumption plan together with MS SQL storage provider for durable functions is not available for me, and that's why I'm not happy. The next thing is about Azure Functions roadmap. So if you will check this roadmap here, you will see that for the .NET Framework 6, which is the current long-time support version of .NET Framework, they do support the Durable Functions engine. They support it only in in-process mode, but nonetheless, they do support it here. The trick is that they support only the durable framework itself. They do not support the SQL provider, because if you will go to this link, if you will check this tiny little note here, you will see that currently, if you want to use the SQL storage provider for durable functions, you need to downgrade your functions to .NET Core 3.1. And this is actually quite a big bummer, because I either need to maintain two different projects. Maybe they will use even the same code base, at least to some degree, but nonetheless, if I want to support two modes, if I want to support, let's say, Azure native consumption plan, additionally to, let's say, Azure agnostic MS SQL based plan for durable functions, then I literally can end up with implementing two different versions of that engine, and I'm not really happy about that. For now, what I've done so far, we were choosing to degrade and use the .NET Core 3.1 for the engine, which actually helped us to maintain only one code base and then just play a bit with the configuration itself. But still, I am not really happy that I can't use the .NET 6 for my Azure Durable Functions if I want to run them in a disconnected from Azure environment. Then the upgrades. Okay, so to answer the question of upgrades, we may need not even a session, but we can easily end up with the whole conference dedicated to this topic. So as you can imagine, there are some expectations how you will do the upgrades, but there is always a cruel reality which happens to be totally different from your expectations. If you will have a question of how you can make sure that when you will deploy the new code version due to, I don't know, let's say some bug fixes or new features or some other kind of stuff, how you can make sure that you will not mess with all the other instances that are currently running. In my example, we were implementing that under the assumption that the flow itself will not run for more than 2 hours. So technically speaking, in our case, there always was an option, let's say, to pause the orchestration itself and stop receiving all the new orchestration, let's say, all the new orchestration tasks, then wait 2 hours for all the instances to finish, do the rollout, and then unblock basically this pipe and all the requests that were staying there, that were collecting there in a queue, just let them flow and do the magic here. But again, that was kind of possible in our scenario, but I'm not sure that that will be possible in your scenario because your workflows may run much longer. You may have much bigger load than we had in this case. So that is why the recommended answer will be to mimic the new deployment, for example, using the different task hub names. And I know that this particular statement maybe creates even more questions that actually answers the original question, but nonetheless, we will definitely talk about this topic, but not in the scope of this presentation. Based on that, if you have any questions, feel free to ask them. If you want to check the source code that I've presented, you can do that using the following link or using the QR code that you can see on the screen. And I also do have one question for you. So, do you believe that what we implemented so far, was it worth it? Let me know.